Hello class, welcome to Algebra Lesson 1-5, which is all about solving inequalities in one variable. By the end of this lesson, you should be able to solve and graph inequalities. Alright, so let's get started with this first problem, just solving inequalities. This is really similar to just solving equations, except now instead of an equal sign, we have greater than, less than, greater than or equal to, less than or equal to. Okay, so let's start by solving this problem. So we want to isolate x. We want to get x all by itself. So right now, you can see I have negative 4 times the quantity of 3x minus 1 plus 6x is greater than or equal to 16. I'm going to distribute so that way I can get rid of these parentheses. So negative 4 times 3 is negative 12x. Negative 4 times the negative 1 is a positive 4 plus 6x is greater than or equal to 16. Now if we combine like terms, I have a negative 12x and a positive 6x. If I combine those two, I have a negative 6x plus 4 is greater than or equal to 16. Now I want to work towards getting x by itself, so that means I need to get rid of this 4. So since it's a positive 4 plus 4, I'm going to subtract 4 from both sides. So I have negative 6x is greater than or equal to 16 minus 4 is 12. Then I have negative 6x is greater than or equal to 12, so I need to divide both sides by that negative 6. So I have x, and then 12 divided by negative 6 is negative 2. And then a rule that you may remember from pre-algebra is anytime you multiply or divide both sides of an inequality by a negative, so when you're moving that negative from one side to the other, you need to, by multiplication or division. So moving a negative using multiplication or division from one side to the other, you have to flip your inequality sign. So instead of greater than or equal to, it becomes less than or equal to. Okay, then I need to graph my answer as well. So I'm just gonna label my number line here. And I have less than or equal to negative 2. So at negative 2, I'm going to put a circle. And then I need to stop and think, if it's greater or less than or equal to, or greater than or equal to, whenever you have that or equal to, you always have to fill in your circle. If it was just greater than or less than, you would put an open circle. Okay? All right, and then x is less than or equal to negative 2. So what numbers are less than negative 2? That would be negative 3, negative 4, negative 5, and it would continue going on that direction on the number line. Okay, so now I want you to take a moment to solve this inequality, type that answer in, and I also want you to take a moment to write the inequality down, or like graph the inequality on your paper, so that way you can compare it to mine at the end. Good luck. All right, for this problem, hopefully you ended up at h is greater than or equal to negative 1. And then your graph should match what I have at the bottom of the screen there, a closed or filled in circle at negative 1, and then the arrow pointing to the right towards the positive numbers. If you were someone that ended up with h is less than or equal to negative 1, you made a really common mistake. And that common mistake is you saw this negative sign, so you automatically assumed you had to flip your inequality. But this negative sign did not move from one side of the inequality to the other, so you did not have to move or flip that sign, okay? All right, example 2, just more practice, okay? We have this time an x term on both sides of the inequality. So what I want to do first is I want to get my x terms all together. So I'm going to move the smaller of the x terms, so I'm going to subtract 1.5x from both sides. So then I'm left with 2x plus 19 is greater than negative 7. And then I want to get that x by itself, so I'm going to subtract 19 from both sides. I'm left with 2x, I still have it is greater than negative 26. Then I'm going to divide both sides by a positive 2, and since I'm dividing both sides by a positive, I'm going to leave my sign the way it is. So I have x is greater than negative 13. So then on my number line, I'm just going to put negative 13 in the middle and then just write a couple of numbers on either side of it. Okay, and then it's just greater than, so that means it's going to be an open circle. And then what numbers are bigger or greater than negative 13? That would be negative 12, negative 11. I'm pointing towards the positives. Okay, so that would be my graph. All right, now it is your turn to try. Good luck. Okay, and so my final answer, I ended up with f is greater than 4, which if you graphed it, you would have an open circle at 4, and it would be pointing to the right towards the bigger numbers, okay? If you have any questions on that, please be sure to ask for some help. Let's move on to example 3. Now we're just going to practice solving inequalities, okay? So I'm going to be done graphing for now. If you have questions on graphing, please reach out for some help. So I'm going to start this problem by distributing a negative 3. So negative 3 times 2 is 6, and then I have an x. Negative 3 times a negative 5 is positive 15. And then I have negative 6x plus 9 on the other side. I always want to get my variables together on one side, so I'm going to add 6x to both sides. And if I do that, negative 6x plus 6x, that cancels out. That becomes a 0. So I have 15 is greater than, and then negative 6x plus plus 6x, that's 0. So then I have 9. Okay, so you might be thinking, okay, the variable's canceled. We lost our variable. What do we do? That is a great question. So if you end up with a situation like this where your variable disappears, okay, we're left with 15 and 9. What you want to do is read what you have left. So in this case, if I were to read this, I would say 15 is greater than 9. And I want to stop and think, is this true or is this false? Because if it's true, that is infinitely many solutions. And if it's false, then it is no solution. So 15 is greater than 9, so I know that my answer is infinitely many solutions. Had it been something like 3 is greater than negative 2, that would be considered a no solution situation, okay? So if it ends up being a true statement, it's infinitely many. If it ends up being something that's not true, that's false, you're going to write no solution. Okay, so that's why this answer is infinitely many. All right, let's try another one. So I have 4x minus 5 is less than, then I'm going to distribute 2 times 2 is 4x, and then 2 times negative 3 is negative 6. So then, again, I have the variable on both sides, so I want to combine those. I'm going to subtract 4x from both sides. Now I'm left with negative 5 is less than negative 6, which can get a little confusing. You might just look at that and say, oh, 5 is less than 6. Good, we're good to go. Except these are both negative. So that's a little tricky. So this statement is actually false. So this would be a no solution situation. All right, now it's your turn to solve this one and tell me, is the answer infinitely many or no solution? Good luck. All right, for this problem, hopefully when you distributed, you ended up with negative 8x, negative 8x, wow, words are tough. Negative 8x plus 4 is less than negative 8x plus 4. Okay, so maybe you looked at that and you're like, dude, it's the same thing on both sides. We're good to go. Infinitely many solutions. But careful. If you add 8x to both sides, you are left with 4 is less than 4. Is that possible? Can 4 be less than itself? No. So this is actually a no solution answer. If you have questions about that, please be sure to reach out for some help. All right, example 4. This is our last example for today. Derek wants to order some roses online. For what number of roses is it less expensive to order from Florist A, from Florist B? Okay, so we want to figure out which time will it be cheaper to order from Florist A. practical solution, right? You want to save money. Okay, Florist A. Cost is $4.75 per blue rose. So I'm going to do 4.75 R because it's $4.75 for however many roses we buy. And then a delivery charge of 40. So no matter what, I have to write 40. Okay. Then if we look at that, okay, for what number of roses is it less expensive to order from Florist A? So I'm going to do less than, and then Florist B would be 515R plus 25. And now I just solve it. So Florist A, if I keep going from there, I'm going to subtract 475R from both sides. I'm left with 40 is less than 40 cents times R plus 25. Then I'm going to, subtract 25 from both sides, minus 25. 40 minus 25 is, 15. 15 is less than 0.4 R. I end by dividing by 0.4, divide by 0.4, and, oops, I just need to scroll. So then if I keep going from there, 15 divided by 0.4 is 37.5 is less than R. So can you buy half of a rose? No. So I'm going to say it's cheaper to buy from Florist A if it is more than 38 roses. So then when would it be cheaper to buy from Florist B? When it is the opposite of that, right? Less than 38 roses. All right. So if you have questions about that, please be sure to reach out for some help. And then here's a nice little screenshot. Some of you like to take screenshots for notes, so this is a good page to take a screenshot of. It gives you kind of the basics for solving inequalities. If you have any questions at all, please don't hesitate to reach out. I'm more than happy to help you. Have a great day.